Okay, welcome everybody. So I'm going to give you the notes from section 14.1. Okay, so this is section Section 14.1, greatest common factor. So one class, we had the greatest common factor, but it was about 3 weeks ago, so I want to review that. And I want to talk about the examples. So you have a PowerPoint from section 14.1. I want to go over the examples and I'm going to explain what I'm doing with each example, which I'm about to do. So this is example 1. Identify the greatest common factor. So you need to find the greatest common factor, which is the shortcut GCF of each. Okay, so A, we have 24 and 30. So the greatest common factor is the greatest number in this case, because we're talking about numbers. Which can divide both 24 and 36. So most of the time when you're looking for greatest common factor, you can quickly figure out, okay, originally that's supposed to be 36. So you have 24 and 36. So the greatest number which can divide 24 and 36 will be 12. Greatest common factor equal 12. Since 12 divide 24 and 12 can divide 36. B, we have to find the greatest common factor. Now you have 105, 40, and 60. So you have to think greatest common factor. Okay, it's an integer because we're talking about integers here. The greatest integer. The greatest integer which divide all 3 numbers. Okay, 105, 40, and 60, and the greatest common factor will be 5. 5 can divide 105, 5 can divide 40, 5 can divide 60. So GCF equal 5. In case if you struggle with finding greatest common factor, okay, if it doesn't come so fast for you, so I can review how to do it with the tree factorization. So note, if you're not sure what is the greatest common factor, use tree factorization. So 3 factorization, what you're going to do, you're going to take the first number, which is 105, and you're going to rewrite using prime numbers. 105 has to be rewrite using prime numbers. So prime numbers, that's the numbers which are only can be divided by 1 and by themselves. Prime numbers, example, 2, 3, 5, 7, and so on. Again, that's the numbers which can be divided only by 1 and by themselves. So how are we going to do it? So I'm just going to show you quickly one example, because most of the time when we have integers, students quickly can figure out what is the greatest common factor. The first prime number is 2. So, excuse me. The first prime number is 2, but 105 cannot be divided by 2. The next prime number is 3. So 105 can be divided by 3. And 105 divided by 3 is equal to 35. Now I'm talking about 35. 35 can be divided by, again, and you're trying to find on the left side of the tree, you're trying to have a prime number, so 35 cannot be divided by 3, cannot be divided by 2, so the next prime number is 5. So 35 can be divided by 5, and that will give me 7. Now you guys see that 3, 5, and 7 are all prime numbers. So what that shows you, that 105 is the same as a product of 3, 5, and 7. And I'm going to do that the same thing for 40, because we're trying to find the greatest common factor between 105, 40, and 60. 40 can be divided by 2, you're getting 20. 20 can be divided by 2, you're going to get 10. 10 can be divided by 2, you're getting 5. So you're going to stop when you only have the prime numbers. So 40, it's the same as 2. 2 repeats 3 times, which means 2 to the 3rd power times 5. And I'm going to do the same thing for 60. 60, it's divided by 2, I'm getting 30. 30 divided by 2, I'm getting 15. 15 divided by 3 will give you 5. So again, 60, it's the same as 2 times 2 times 3 times 5, which is the same as 2 to the 2nd power times 3 times 5. Now when you have a prime factorization of each number, to find the greatest common factor, what you're going to do, you're going to take the factors which repeat in each. And if you're going to have exponents, you're going to pick the lowest exponent. So the greatest common factor, okay, let's see. 105 has 3, 40 does not have 3, 60 has 3. So 3, it's not one of the factors. 105 has 5, 40 has 5, and 60 has 5. Since 5 repeats in each number, so we're going to put 5 times. Now, next we're going to select another factor which repeats in each. Again, 105 has 7, 40 does not have 7, 60 does not have 7, so technically we only have a 5. So the greatest common factor is 5. Okay. Next example. Identifying greatest common factor. So this is example 2. Find the GCF among from each group. So this example is different because what's happening here you're going to have not only integers but also variables and exponents. So I'm going to solve example A. We have 7x to the third power 14 x squared and then 21 x to the 4. Okay, so first what we're going to do, just find GCF of each integer of 7, 14, and 21. So you have to think, what is the greatest number which can divide 7, 14, and 21? And the GCF of those three integers will be 7. Okay, next, second, find GCF of x to the third power, x squared, x to the 4th power. So when you have a variable, the greatest common factor is the expression to the smallest exponent will be x squared. Again, note, pick the repeated variable with the smallest exponent. Okay, so third, you're going to combine all of them together. Greatest common factor of 7x cubed, 14x squared, 21x to the 4th power is 7, because that's what we have for integers, and times x squared, because that's what we got from variables. Okay, so we're going to do example B. Find the greatest common factor. You have 15a to the power of 4b, 25a to the 3rd power, and b squared. So the same idea, GCF of integers, which is 15 and 25, is 5. Again, you pick the number which can divide 15 and 25. So 5 is the largest one. And GCF of A, now I'm going to combine the variables. So I have a to the power of 4 and a to the 3rd power is a to the 3rd power. Again, pick the variable which repeats with the smallest exponent, and GCF of b. And so I'm organizing them, integers, then I pick a, then I'm working with b's. And b squared is b. Again, you pick the variable to the smallest exponent. And now you're going to rewrite all of it together. So, greatest common factor of 15a to the power of 4b, 25a to the 3rd power, b squared, is 5a cubed b. That's your final answer. Okay, I'm going to stop this video. I'm going to upload on YouTube. I'm going to make short videos so it's just faster and easier for me to upload. and I will continue with the second recording. Okay, thank you.